one aspect of the graph of motion, linear motion, that we need to actually get, one other concept that we need to actually evaluate is the distance of travel. And then we say the distance of travel is calculated from the areas under the graph of the motion. So when we have the graph, or the area under the graph, that total area is the total distance traveled. That's how we get the distance. So now we need to actually know how to evaluate that distance over time. And then in order to do that, there are some common figures that will show up when we are able to demarcate the area under the graph into different portions. So they will result into giving us different figures. And then there are three common forms of figures that actually come. And then these are the three ones. We have rectangle. They can come in rectangle or square form, just like this case. That's one. They can come in the form of right angle triangle. I repeat, right angle triangle specifically, or you can see them as trapezoid. So when we'll be demarcating the areas under the graph into various portions. When we are doing that, we will see that under the area under the graph, after doing the demarcation, they will all result into at least one of these. Then we'll calculate because there are normal ways or constant way of evaluating the areas of these individual figures. Then that's what we use them. So let's go over some of the mathematical evaluation of the area of each of them. For rectangle or square, so we have this unit A, right? It should be area A times B. That will give us the area of a rectangle, or square. So this should be A times B. A times B will give you the area. So if you become a square, so you need to be able to evaluate this side and also evaluate this side. You multiply them to get the area. For right angle triangle, is half base times height. So the base, which is this side, from here to here, and then the height is the height here. So we should be able to evaluate all that in order to get the area. And then when you look at this side as well, what we have trapezium or trapezoid as called by some people. Look like triangle, but a rectangle, but we have parallel sides. So we are interested in the parallel sides. So which is we sum them. So A plus B, we sum the parallel side. So this one plus this side, multiplying the height. That's the separation between the A and the B, the parallel side, the distance between the parallel sides. Then we have it. That will give us the area of the trapezium. Right. So these are the basic things to know about this common figure. They are three, so we look out for them. So when we demarcate, we need to have at least one of them. So the example that we have already, let's look at how to demarcate those. So this is the first one. We've done this in the previous session, so we kept them so that we will be able to evaluate everything on it. And then so for the area under the graph, for this particular one, it moves from here to here, right? Let me use another color, use color red. Be able to see that the area under this graph will be, so if I put it here, make sure you put it to the time axis or the x-axis. So this is the entire distance includes the area between the graph and then the horizontal line. This is the total area. So at the end of the day, what are we having? What shape are we having? We are having a right angle triangle, which is in this form. You can see that, right? We have this side, and we have the base. So that's one. Let's also go and demarcate the rest. So these are the evaluation we did in previous session. So let's clean it up to have the board doing for us. Then we can. So what shape do you think we'll get over here? So between the graph and the t-axis, we are having what? Another right angle triangle again. So we have right angle triangle again. So let's go again to this one that are combination of lots of them, right? Let me delete this side. These are from previous sessions. So when we're calculating acceleration, deceleration, and all that. Okay, so now let me delete this side as well. All these explanations. So here, from here to here, that means so we can cut this side like this, and then from here to here, we can cut this side like this, right? We can cut this side like this to have this particular shape. But then whenever you have rectangle, triangle together, what you can do is that you can combine them to just have a trapezium. You can just combine them to have a trapezium. So this one, let's do it like this. Let's do this one like this. Let me give another color to this one. Let me give a yellow color to this one. So you can see we have a rectangle, triangle, and then a rectangle over here. That's the shape. So let's go to another figure. So let's look at this figure. This one, I will do all the two that we need to do. These two figures. These guys are not needed anymore. These calculations are not needed anymore. We them. And let's look at what we can do here. So there is one side here. So this whole side can give me a triangle. This side to this side can cut this side, demarcate this side. We will give another color. We'll give another color to this guy. I'm going to have another area here. And the last one here, these guys will be like another color. We give another color to this guy. So there's 1, 2, and 3. But you know what we can do? We can just clean all this side. Right? We can clean all these things and then consider them all of them as one. Consider all of them as one. When you consider all of them as one, you are going to have a trapezium with all. Like we said, we are going to have trapezium with all. So you see the shape of trapezium, right? When you consider all of them. So you also have a trapezium when you have a rectangle beside a triangle. So rectangle plus triangle together will give you a trapezium. So you can look into that as well. Yeah. Yeah, this is a trapezium. You can consider the trapezium, this one. Let's look at another one. Yes. We have something like this. Something like this. Let me delete this side. I did a mistake. During the deletion. Okay. So let's see what we can do for this people. This place, I actually evaluated a lot of things. So let's just do this one and then give the rest of it for you to try, right? So let's see how you can find this. So from here to here, from here to here, so let me cut it like this. Let me use another color. Let me cut it like this. So I'm going to have this from here to here. It's not the rectangle, but we have this. Then we have this. Right. So if you cut this one, we move from here to here. We have one shape here. This you see, I see one parallel to this side, this side parallel to this side, this side parallel to this side, and this side cannot parallel. So this is a trapezium. This is a trapezium. So that's the approach that we do to that one. So look at this one as well. So from here to here, this is definitely right angle. Right angle. Let me give it a different color. Color. Okay. I will just actually a different color for you. So this guy should be blue from here to here. So the boundary between the this guy give us another square or rectangle, right? Square or rectangle. We give another color, give another color here. So here, then this last side, for this last side, we are going to have from here to projection downward this side. What shape do you think we have there? What shape do you think we have? So we have a parallel side, we have this, but we have this one which is being parallel to this side of this, right? So there's two parallel sides, and the other two are not parallel. So that will be a trapezium as well. So we have a rectangle, we have a rectangle, we have a trapezium, we have a trapezium. So that's how you do the demarcations along sides. So try for this one I've done. Try for this as well. And then let's see what you get for these sessions. So the next session will be taking time to actually evaluate the total area under the graph using these figures that we have used to demarcate all the various portions. Right, go to the first, let's do step by step, go through the steps of be able to demarcate and have your various figures well under each of them before we continue evaluating, moving on from there. See you in the next session.